Hello, my name is Kainson Munonye. I'm the application developer, and here in this presentation I'm going to discuss search techniques and algorithms in artificial intelligence, and then I'll also discuss implementation using Java. Well, search algorithms or search techniques apply to different areas of study, but particularly I'm discussing it under artificial intelligence. Okay, so what are the various search techniques we are going to discuss? There are basically four of them, but we'll be focusing on two: the depth first, the breadth first search, the hill climbing search, the least cost search. The four of them we are going to discuss, but we are going to focus on the first two, and the implementation in Java. I'm going to show you the implementation for the first two. Okay, so let's take the first one, the depth first search. The depth first search explores each possible path to its conclusion or goal before it tries another path. So you have a situation whereby the depth first search searches vertically down the tree to the very leaf, and then it takes another path to the leaf. Okay, so how does it work? Let's take, for instance, if we are going to search for K in the list. Let me make some annotation so that we'll get the point clear. Assuming we are searching for K, so how is it going to traverse the list? It will start from A, B, D, H, P, okay, comes back and takes Q, comes back to D and takes I, R, comes back and takes S, goes back. Now is going to take this path to E, and then J, and then K. So if we are going to write the nodes encountered, we have A, okay, then we have B, the next one is D, the next one is D, and the next one is H. Oh, don't mind my writing here. Then we have P, then we have Q, okay, then it goes back to H, it goes back to H, okay, and so on and so forth. So continue until it gets to K. I'm sure you understand this explanation. So that is how it works. So this is the algorithm. Maybe you pause the video and take a look at the algorithm. What actually happens here is you start with the first node, okay, and then check the children of that node. The first node you are starting from, you call it the root node. Okay, so you check the children. If it has children, then you now remove the first element and put back the children to the queue. I don't know, but I think we may just have to look at the Java implementation right now. So let's go to NetBeans and look at the Java implementation. This code, I might make it available. You can check the description box there, and I'll have this code there for you. So the depth first search, I would just like you to take a look at the code, and then you can now try to do it yourself. But for now, just take a look at the code. I'm just going to explain to you parts of the code, not everything, so that you know exactly what happens. Now, the depth first search procedure is a recursive one. So it means that, let's go back to this presentation so that I try to tell you exactly what is happening there. Okay, we have this. So we have recursive means it starts with this, okay, goes to the left child, okay, and you have this tree here. It goes to this tree, it goes to this tree, it goes to this tree. So it's continually carrying out depth first search as it breaks down the whole tree into subtrees. So that's where the recursion comes in. So let's go back to run the Java program to see how it actually works. So I don't think I'll make much explanation, but just take your time to go through it, and I think you'll find it easy to understand. The tree is built using the numbers, the letters of the English alphabet there, and it is implemented using a stack data structure. So if I just run it, okay, so assuming I want to search for P, okay, so depth first search is going to move from A, B, D, H, P. So let's check it out. Assuming I want to search for P, A, B, D, H, P. As you can see, A, B, D, H, P. So it goes vertically down the tree from the root to the leaves. So that's the implementation in Java. It took me some time to be able to figure it out, but I think you'll find it quite easy. So let's move to the next one, the breadth first search. This one is actually the opposite of depth first, because it checks the nodes on the same level before it goes to the next level. So here we have this A, B, C, D. So assuming we want to go for F, so it starts from A, okay, it goes to B. On the same level with B we have C, then we have, it goes down the next level there, that is D, and then it goes to E, okay, and then it finds it in F, and that's just that. So I'd like us to look at the algorithm first before we move to the Java program. Now the algorithm is similar to the depth first search algorithm. The only difference I want you to take note of is the number 4 item that says if the first element is a goal node, remove the first element from the root, remove the first element from the queue. I think this is a typo, and add the first element's children, if any, to the front of the queue. That is the only difference there. So let's go to NetBeans and take a look at the breadth first search, and let's just run it. Breadth first search is implemented using a queue data structure. Remember we mentioned that depth first search uses a stack data structure. Now the breadth first search uses a queue data structure. So what I'm going to say is I'll say run file. Okay, so let's look at the tree we are working with. Okay, yeah, it's tree. Okay, this tree. So assuming we want to find G, the breadth first search will search this tree in alphabetical order to find G. So it's gonna be A, B, C, D, E, F, G. So let's go back to NetBeans and try to run it. So G, search for G, okay, A, B, C, D, E, F, and G was found right there. So that is how the breadth first search. This code, you can get it there in the description box below. Let's proceed. Now we have the hill climbing techniques is defined to be improvement of the depth first search. it chooses as its next step the node that appears to place it closest to the goal. Okay, so it means that for it to make a choice for the next step to move, it has to have some idea of the whole structure of the tree and estimated distances to the goal. Okay, so it says in many situations single measurement can be made to determine a reasonable ordering, and hill climbing is depth first search with a heuristic measurement that orders the choices as the goal are expanded. So before it chooses the next step, it's going to sort the remaining children of the current node. Okay, it sorts the remaining children in decreasing order of estimated distance to the goal. So what it means is, let me see if I've got the illustration. This is the algorithm, maybe just take note. Okay, so now I have 21 from C. Now the next step, moving uphill. Okay, now 21 is the highest. Is the highest. I assume we are here in B, so it's instead of moving 17, 20, it will move 50. Okay, so it moves uphill in the direction of increasing estimated distance to the goal. So that's about hill climbing search. And now we have least cost search as the opposite of hill climbing search techniques, and it takes the path of least effort, which is the lower estimated distance to the goal is taken. So number 5 item on the search algorithm says sort the first element's children in decreasing order of estimated remaining distance and add the first element remaining children to the front of the queue. And this item point here is the only difference. Sorry, I think this is to the back of the queue. For the hill climbing is to the front of the queue. Okay, so now if we are going to compare the search techniques, how can you make a choice of which search techniques to use? Now the search problems can be divided into two, or the search techniques have two categories. One, those that heuristics can be applied, those that heuristics cannot be applied. Okay, so what is heuristic? Is a technique that approaches a problem. I am employing practical methodology not guaranteed to be optimal or perfect, but sufficient for the intermediate goal. So heuristic means searching, okay, by moving to the best possible option at that time. I think heuristics is not is not covered much in my presentation, but take note that heuristics finds the best or the optimum value to be the next step to take. So it searches by applying the best possible option, and the definition here you can just get it right into your head. And so if you cannot apply heuristics to a problem, then probably you use the depth first search. Now you have an exception only if you are sure that breadth first is going to work better. But if you cannot apply heuristics, you just use the depth first search. Now hill climbing and least cost, how do you choose? It depends on what constraint you're trying to minimize. If you are trying to minimize the efforts, okay, then you choose the least cost. But if you are trying to minimize the number of nodes visited, you now go for the hill climbing. But for least cost, it means you requires little effort. Then hill climbing, less number of nodes to be traversed. Okay, this is where I drop my ammo, and I would like to thank you for viewing. Thank you very much. If this has been informative for you, give me a thumbs up, subscribe to my channel, and also leave a comment on what you want me to do. Once again, I'd like to thank you for viewing.